Okay, how do we convert from particles of one reactant into particles of a product on a balanced chemical equation? Well, the answer is stoichiometry, and that's what we're going to be talking about today. So let's just define what stoichiometry is really here real quick. And so this is the portion of chemistry that's going to study the relationships between amounts. Amounts is our big deal. And they're amounts of reactants that are always found on the left side of the period or of a balanced equation, and products which are found on the right side of the period or a balanced equation. So stoichiometry is studying the relationship. So we can use stoichiometry, and this is what we're going to do with it, is we can determine how much of a reactant we need to make a certain amount of product, how much of a product is made if we know how much reactants we have in a chemical equation. So you will need a mole road for this. And if you don't have a mole road, talk to Camp because he will give you an extra copy of the mole road. And this is a clean mole road right here. So I'm going to go ahead and add a few things to this that you should already have on your mole road. So volume at STP, we know that that is measured in liters. Our representative particles are going to be atoms and molecules and formula units. And of course, down here at the bottom, we have mass, which is measured in grams. And we know this mole road, we've used it to convert between grams of one thing and moles of the same thing, or liters of something to moles of something. We're going to add one additional piece to this mole road. And this is what I'm going to do. I'm going to start at the mole here, and I'm going to put an arrow that kind of swoops back around and goes right back to the mole. Now, what conversion factor I'm going to use here is I'm going to use the unknown coefficient from a balanced equation over the known coefficient. Okay, so unknown over known. And where we get these values are from our balanced equation. They are going to be our coefficients. And this is what I mean by that. So I'm going to scroll down here real quickly. And I've got a chemical reaction down here. And in this chemical reaction, we have two sodiums reacting with two hydrochloric acids to form two sodium chlorides plus one hydrogen. We can also say that we have 2 moles of sodium reacting with 2 moles of HCl to produce 2 moles of NaCl and 1 mole. So those coefficients there, these coefficients represent individual atoms or molecules, but they also represent moles, and that's going to be a 1 there. Okay, and so we can use this, and these values, these 2 moles, 2 moles, 2 moles, and 1 mole, is what we get from the balanced equation. It allows us to convert from moles of reactant to moles of product, or moles of product to moles of reactant, or even moles of reactant to reactant. Anywhere we want to go on the mole road. So let's walk our way through a problem here. And so here we have a sample problem. It says, if 5.5 moles of sodium are reacted with excess HCl, how many moles of H2 gas will be produced at STP? So there's a couple things we need to look at here. The first thing is we have a known. There's our known value. 5.5 moles of sodium are known. We also have our unknown. How many moles of H2? So we're looking for moles of H2. There's also something else in this equation. It says excess HCl. Now, one of the things that whenever we see excess in a stoichiometry problem, that just means we can ignore it. Just ignore it. There's plenty of HCl to go around. We will never run out of that HCl. So let's just forget about it for the moment. Later on, we'll take that into account. But now we're not worried about it. So what we're going to do is we're going to set this problem up just like we set up most mole problems. We put our known value right here in the upper left-hand part of our picket fence. So we have 5.5 moles of sodium. Okay, there's my known value. My unknown value is right there, moles of H2. So I'm going to write moles of H2. Okay, so what I'm doing is in this reaction, or in this problem rather, I'm starting off with moles of one thing, and I'm ending up at moles of something different. And so in order to do that, I need to start here at the mole. And I'm going to go right around this conversion factor, which is the unknown over the known. Unknown over the known from our balanced equation. So I'm going to come back down here to my reaction. Unknown is H2, and I'm going to get the coefficient from H2, which is right there. It's a 1. So I'm going to place a 1 there. Now my known is moles of sodium. So I'm going to write moles of sodium on the bottom. And then I'm going to look at the balanced equation, and there's the balanced equation for sodium right there, and the coefficient is 2. And so we have 5.5. We're going to still do the same thing as we did before. We're going to multiply straight across the top, 5.5 times 1, and then we're going to divide that by 2. Okay, and 5.5 divided by 2 gives us 2.75. We have to look at the number of our sig figs. So we have 2 sig figs given here. So this is 3 sig figs. I'm going to go ahead and round this off to 2.8. And then the unit that we're going to be left with is moles of H2, and that's how many moles of H2 get produced. So that's our first problem. Let's try one more problem and make sure we're on the right track with this. Same balanced equation on this guy. And so it says, let's identify first off our known. How many moles of HCl will be required to completely consume 15 moles of sodium? So 15 moles of sodium is going to be our known, and moles of HCl is our unknown. Okay, so let's go ahead and do a problem. Our known always goes in the upper left-hand quadrant, 15 moles of sodium. Our unknown, moles of HCl. Okay, so again, we have a problem where we're going from moles of one thing to moles of something completely different. So let's grab a mole road really quickly. And I just posted a mole road down there. So again, we're doing this moles to moles conversion, and we're going to do the unknown over the known. And again, those numbers are going to come from our balanced equation. So our unknown is listed here already as moles of HCl. So I'm going to look up, there's my HCl. So I'm going to have 2 moles of HCl on the bottom. We're going to put our known, which is sodium, so moles of Na, and there's our moles of Na. So it's a 2-to-2 ratio. So it's going to be 15 times 2 divided by 2, which is basically 2 over 2 is 1 over 1. And so our answer is 15 moles of HCl because the coefficients are the same. And that's how we do a moles to moles stoichiometry problem.